In this video, we are going to talk about the properties of powers and about radicals. Now here, this is going to be mostly a revision from what we have learned before. Now we know that if a number is positive, if it is raised to any power, then it stays positive. Example, 7 to the 6 is positive, 7 to the 9 is positive. If the number is negative, if it is raised to an even power, it will become positive. If it is raised to an odd power, it will remain negative. Example, minus 3 to the 4 is positive, minus 3 to the 5 is negative. Now, properties of powers. Again, this is also a revision. We know if in multiplication, if we have the same base, we add the powers. In division, if we have the same base, we subtract the powers. If we have a times b raised to a certain power n, then we distribute the powers. So we will have a to the n, b to the n. Same thing with division, a over b to the n, we distribute the power, so it will be a to the n over b to the n. If a power is raised to another power, we multiply the powers, and any number to the power 0 is 1 except for 0, so a should not be equal to 0. Now the square root, we know that the square root is the inverse operation of the square, so the square root of 100 is 10. The square root of 10 squared, we can cancel the square with the root because 10 is positive, so it becomes positive 10. If we have the square root of minus 10 to the 2, the minus raised to an even power becomes a plus, so the answer is 10. Now, in general, the square root of x squared, whenever we have a variable, we have to put absolute value of x. So absolute value of x is equal to x if x is positive and equal to minus x if x is negative. Now, computation rules for the roots. We know that the square root of a times the square root of b, we can make one big root and we put under it a times b. The same thing for multiplication, square root of a over square root of b equal one big square root and under it a over b. If we have radical a to the n, it's equal to the square root of a to the n. Example, square root of 7 all to the power 3 is equal to square root of 7 to the 3. Now, cube root. We are so much familiar with the square root, but not so much familiar with the cube root. The cube root is the inverse operation of the cube of a number, and this is the symbol of the cube root. We put a root and we put the index of the root here. We put a 3. This is the cube root. Now we know that 4 to the 3 is 64, so the inverse operation, the cube root of 64, will give me 4. 5 cube is 125, so the cube root of 125 is 5. Now here is the difference between the square root and the cube root. We have minus 10 to the 3 is minus 1000, so we do have the cube root of a negative number, which is minus 10, because we know that the negative number raised to an odd power is negative, while a negative number raised to an even power is positive. That's why we don't have the square root of a negative number, but we have a cube root of a negative number. Minus 6 cube is minus 216. So the cube root of minus 216 is minus 6. Here, this should be a cube root of 3. Minus 8 over 27 is minus 2 over 3. So the cube root of a number could be negative, and we could have a negative number under the cube root.